Hi, today we have a board. Watch, look out at the fucking beautiful explosion. This is a pin and just exploded from the circuit and went here. That's the source. And then here, just blow the fuck out of it. Fuck, everything is metallic around here and here. What a mess, what a mess. Yeah, today we have an old Autopilot. This one it's a 400G and it's a Raytheon. But I don't see anything about the G. The G model has here the gyroscope that's inside. This one I took it out and did not have it. Now look at the interesting part. Just blow the fuck out of the MOSFETs on the output. And this is not usual. You almost never find them blow up like this. Now, the way the circuit is built, it has around here, it has two circuit integrates. This one it's an LM324 or 339, I don't remember it. And the other one is 74HG14. So it has a current limit. I think this is the resistor. Maybe, or if not, it's reading. No, this is the resistor. This is the shunt resistor. So the electronics always read the power consumption that you have on the MOSFETs, and if you short circuit the output, it will just go in protection, current limit mode, and will not allow you to blow up the fucking MOSFETs. Now, in order to blow the MOSFETs, two things: either a lightning strike, or it happened to me once, one of the two terminals goes to short to the ground because the motor or the pump, the actuator goes short, or one of the cables go to short to the ground. Now this MOSFET together with this MOSFET work as a half of the H bridge, and those two are the other ones. You have like too low and too high, or the other way around. I don't remember which it's which. And it has the control over the whole H bridge. Just that whenever a short circuit on one of the terminals occurs in the boat, it will blow up the things. Now let me just grab a pen and I'll show you how this system works. Now this is the general schematic of an H bridge. So this is the positive, and down here is the negative. You have the motor in the middle, and you have the four MOSFETs. Now, whenever you give signal, let's say to this one and this one, from here the positive will open to the open MOSFET, so it will give the positive to the motor, and the negative on the other terminal, so the motor will spin clockwise. When you turn off those two and turn on these ones, this one and this one, in that case it goes negative here because this one stays open, and positive here, so the motor will go on the other way around. Now why I keep talking about current limit and the proper protection on the output of these Smartpilots and so on? Because it has a shunt resistor. I don't know if this one is on the negative or on the positive side, and it reads across this resistor the voltage drop, how much current does it pass through this one. So whenever the current drop, if you say in the menu type 3 drive, it is the linear type, so it knows how many amps the linear drive it's drawing, and beside that it modifies the PWM command. So it will give a small impulse and then a big one. So it starts slowly, the type 3, the linear one. Instead, for the type 4, it is a much bigger current, and the PWM type, it's almost it's going high all the time, just big PWM, big power. So it knows how much current will pass in this resistor. So whenever you block the output, the helm, a big wave blocks the helm, or someone keeps his hand on the helm, instead of blowing the fuses or burning the MOSFETs on the final, we'll just go current limit and we'll stop, we'll go on standby. Now, if you take this one, let's say, and just connect it to the negative, shorted, one the terminals that goes to the motor, you short it to ground, doesn't read it from here. Yeah, it's on the negative, this one. It doesn't read it. Let me just check. I think we can check it real fast. Now, this one. So the negative should be like one of those two. It's not here. It's not here. What the fuck? Maybe it's not on the negative. Or maybe that's not the shunt resistor. It is on the output. Anyway, now I will desolder all the MOSFETs. I will give it a good cleaning and take a couple of measurements, but it is never freaking that easy that you just take out the MOSFETs, you replace them, and it starts working again. Now, at the first glance, I cannot see. Yeah, this one. It is. I don't know if this one. It is a little bit signed, like blown. I will measure it and see what's going on, and then I'll do a general inspection on it. To see what's going on. Let me see if, yeah, we have a proper zoom. What's going on there? Yeah, I don't think that is normal. Where are you? Like this one? Yeah, that's blown. Let's see what that is. Ooh, another unusual color and thing here. What is that? J, that will be like some kind of Zener diode. Yeah, I will do a proper inspection. I'll desolder them and see if it can be saved. Unfortunately, I cannot save all of them. We have another one. Let me just show you. I've worked like too many hours on it, but I get to a certain point where I just want to know what the freak it's going on. This one, that one power was missing, and then I did not manage to understand where the problem is. This is one of them. Also the final part blown up, and I keep them for the winter, like to see what's going on. And I have another one here. All these instruments are like don't really worth the time. This one, a lot of corrosion and stuff, and also the blown up part, and here replace like all over the world, the current limit, the op amp, all those small transistors around. This one that had like a pin blow up from it, so I had to pass a wire. So this one I did not manage to fix for now, and I don't know if I'll keep losing time on them, because at the end of the day I gotta just see how many hours it takes and just throw them away. Anyway, I hope you like it. Ciao. Yeah, as I told you, it's never that freaking easy. I just solder the MOSFETs. Now watch what's going on. I did put a current limit Let's just go a little bit higher, like 1 and 6. Yeah, never that easy. Couple of hours later, the LED is the clutch, and then you go left and the light goes off and goes right. Yeah, this one is what it was, another tricky one. All the pre-finals, all the protections, the diodes, and it's not yet over because we have a problem. When you started, the compass is not linear, so must be something on the compass circuit on this side. Now I'll see what's going on there. Yeah,